Alright, these are the notes for Algebra 2, Section 3.6, pages 195 through 197 in your textbook. And we're dealing with multiplying matrices. Now, we've already talked about basic matrix operations, adding two matrices together, multiplying a matrix by a scalar, that is, a number that's not a part of the matrix. Now we're going to look at how we multiply two matrices together to get a product matrix. Now there are a couple things that we have to look at before we can actually start multiplying these things together. We have to look at whether or not the matrix is defined after we multiply them together. We can't multiply two matrices together if the result is not defined, right? Just like we can't divide by 0 because we get something that's undefined. We can do a simple check to make sure that the product of two matrices, A and B, are defined. If the product of the two matrices is defined, then the number of columns in A has to equal the number of rows in B. Now we remember that every matrix has dimensions, rows by columns. So if we look at the columns in A, that is the second number in the dimensions of A, and the first number in the dimensions of B, they have to be the same number. If they're not the same number, then the product would be undefined and it's not going to work. Once we know whether or not it's defined, we can figure out what the new dimensions will be. The dimensions of the product of the two matrices will be the rows of matrix A, that is the first number in the dimension of matrix A, by the columns of B, that is the second number in the dimensions of B. I have a little illustration here to maybe help with that. Now we have matrix A, right? This is matrix A, and we see that matrix A has dimensions m by n, so m rows and n columns. Matrix B has the dimensions n by p, that is n rows and p columns. If we want to multiply A times B, the first thing we need to check is that the columns in A are equal to the number of rows in B. And when we put them up next to each other, we can see that the columns in A are n, and the rows in B are also n. So those two are the same. They're equal. So the product of these two matrices is defined. To know the dimensions of the product, we look at the first number of A, that is the rows of A, and the columns of B, the second number in the dimensions of B, and that becomes our new dimensions. So the product of A times B has the dimensions m by p. Now, that might seem like a lot of letters being thrown at you at once. So let's see how this works with a couple of examples. I'm looking at example 1, and we want to state whether the product AB is defined. If it is defined, we want to give the dimensions of AB. So we look at our two matrices. Matrix A is a 2 by 3 matrix. Matrix B is a 4 by 3 matrix. So I look at A and I see that my rows are 2, my columns are 3. I look at B and I see that my rows are 4 and my columns are 3. Now in order for the product AB to be defined, the columns of A have to equal the rows of B. They don't equal each other. 3 does not equal 4. So the product of these matrices is undefined. So because the number of columns in A does not equal the number of rows in B, the product AB is not defined. Now let's look at a different example. We're looking at B here. Now I have two more matrices. This matrix has 3 rows and 3 columns. Matrix A has 3 rows and 3 columns. Matrix B has 3 rows and 2 columns. So in order to decide if the product is defined, I look at the columns of A, the rows of B, and I see that 3 does in fact equal 3. So because A is 3 by 3 and B is 3 by 2, the product is defined. Right? Columns of A equals rows of B. Now I can figure out the new dimensions by looking at the rows of A and the columns of B. So my rows of A are 3, my columns of B are 2, so my new matrix is going to be a 3 by 2 matrix. Alright, now let's see what actually happens when we multiply a couple of matrices together. To find the element in the ith row and the jth column of the product matrix AB, now I'm going to stop for just a second. We see ith row and jth column. That just means a number. I, in this case, is a number, any number. And j in this is also just a number. We throw letters in there just to kind of generalize it, but it's just numbers. So to find the element in the ith row and the jth column of a product matrix, multiply each element in the ith row of A by the corresponding element in the jth row, or jth column of B. Then add the products. And we can see an illustration of that here. Now, as we can see, I have matrix A times matrix B. And here's how this works. The first element of the first row in A is A. And I'm going to multiply it by the corresponding element in the first column of B. So I'm going to multiply A times E in this case, and that's what I got here. Then I multiply B, the second element in the first row, by the second element in the first column of B, and I have B times G. I add the two together, and that will make the first element of my new matrix. All right, so you can see I multiplied A times E, then B times G. All right, so that does it for the first element, but we've got to do this a few more times to get everything else. Now, I want to multiply everything, the first column, or the first row of matrix A times the second column of matrix B. We should be able to see what's going on here. I'm going to multiply the first row of A by the first row of B. Then I'm going to multiply the first row of A by the second, or this first column and second column of B. So that means that I'm going to multiply A times F. First element of the first row, first element of the second column. And that gives me AF. Then I'm going to multiply the second element of the first row by the second element of the first column, or the second column. And I get B times H. And that gives me my second element. I'm on the second row of the first matrix, the A matrix. I'm going to multiply the first element of the second row by the first element of the first column, and I get C times E. I'm going to multiply the second element of the second row by the second element of the first column, so I get D times G, and that gives me my third element. And last but not least, I'm going to multiply the first element of the second row by the first element of the second column, and get CF. The second element of the second row by the second element of the second column and get DH. So let's take a step back and look very carefully at what we've just done. I've multiplied all of the elements in the first row of the A matrix by the first column of the B matrix, and I added the two together. I multiplied everything in the first row of the A matrix by everything in the second column of the B matrix. Then I multiplied everything in the second row of the A matrix by everything in the first column of the B matrix. And I multiplied everything in the second row of the A matrix by everything in the second column of the B matrix. There's a lot of little multiplication and little additions going on in this process, but the more we practice it, the better we'll get at it. Now, let's look at example 2, and we want to find AB if A is the matrix 1, negative 2, 5, negative 4, and B is the matrix 3, negative 6, 7, negative 1. Now, because A is 2 by 2 and B is 2 by 2, the product is defined, and it will be a 2 by 2 matrix because the rows of the first matrix and the columns of the second matrix make up the dimensions of the product. Now, we're going to multiply just like we did in our little practice example here. We're going to multiply the first element of the first row by the first element of the first column. We have 1 times 3. Then we're going to multiply the second element in the first row by the second element in the first column. And we have negative 2 times 7. Then we're going to multiply the first element in the first row by the first element in the second column, and we get 1 times negative 6. Multiply the second element in the first row by the second element in the second column, negative 2 times negative 1. Multiply the first element in the second row of the first matrix by the first element in the first column in the second matrix, and we get 5 times 3. The second element in the second row by the second element in the first column, negative 4 times 7. And last but not least, the first element in the second row by the first element in the second column gives us 5 times negative 6. Second element in the second row by second element in the second column gives us negative 4 times negative 1. Now, if we look really carefully, we should be able to see a pattern forming in our matrix. You can see that I have the first matrix, right here. I have 1 negative plus negative 2. I've got 5 plus negative 4. And I also have the second matrix, but turned sideways. I have 3, both right here and right here, 7 right here and right here. I have negative 6 here and here, negative 1 there and there. And this pattern will hold up. So when you're working on these to begin with, make sure that you keep this pattern in mind. It's very easy to make a simple mistake with this. Now, let's multiply this stuff out. I have 1 times 3 is 3. 2 times, negative 2 times 7 is negative 14. I have 1 times negative 6 is negative 6. Negative 2 times negative 1 is 2. Down at the bottom here, 5 times 3 is 15. And negative 4 times 7 is negative 28. 5 times negative 6 is negative 30. Negative 4 times negative 1 is 4. Now it doesn't give us an extra matrix, but I'm going to draw one in. 3 minus 14 is negative 11. 15 minus 28 is negative 13. Negative 6 plus 2 is negative 4. And negative 30 plus 4 is negative 26. Make sure that you have all of the numbers multiplying in the right order so that you get the correct matrix. All right, so let's multiply this guy out, see what we get. Now I have matrix A and matrix B. I want to first find the dimensions of the product AB. Well, A is 3 rows by 2 columns, so it's a 3 by 2. B is 2 rows and 2 columns, so it's 2 by 2. It is defined because the columns of A equal the rows of B. And our new matrix will be 3 by 2. So our new dimensions will be 3 by 2. That's the first part of our question. Now we want to do some multiplying. Let's start by drawing ourselves a really big matrix so we can shove everything in there. Now I want to multiply 6 by negative 1. Then I want to multiply 2 by 5. That does it for the first element. Now I want to multiply, let's change my color here. I want to multiply 6 by 2 and 2 by negative 2. All right, again, I'm going to change colors. I want to move on to the next row. Multiply negative 1 by negative 1. I want to multiply 3 by 5. Change my color again. I want to multiply negative 1 by 2. And I want to multiply 3 by negative 2. Now you might be able to see the pattern forming here. I'm multiplying the first number of this row by negative 1. I'm multiplying the second number of this row by 5. I'm doing the same thing with the second row. I'm going to end up doing the same thing with the fourth row. I'm going to multiply 0 by negative 1. And I'm going to multiply negative 4 by 5. I'm going to change that to negative because negative plus negative 4 is the same thing as minus 4. Negative 4 by 5. I'm going to multiply 0 by 2. And I'm going to multiply negative 4 by negative 2. So we can see this pattern. All these negative 1s here, all these 5s there, all these 2s here, all these negative 2s there. Now we need to multiply all of this stuff out. 6 times negative 1 is negative 6. Negative 6 plus 10, that is 4. I'm skipping the multiplication step. We should be able to do this in a calculator without too much trouble. Negative 1 times negative 1 is positive 1, plus 3 times 5 is 15, so this will be 16. 0 times negative 1 is 0. 4 times 5 is 20, so it's 0 minus 20 is negative 20. Over on the other side, 6 times 2 is 12. Plus negative 4 is minus 4, so that's 8. Negative 1 times 2 is negative 2. Times 3, or 3 times negative 2 is negative 6. So that's negative 2 plus negative 6 is negative 8. 0 times 2 is 0. Negative 4 times negative 2 is positive 8. So 0 plus 8 is 8. That makes our matrix 4, 8, 16, negative 8, negative 20, 8. And you can see this is a 3 by 2 matrix. Alright, I want you to pause the video and answer this question. You're given matrix A and B, find the dimensions, and then multiply A by B. You'll put your answer on your note sheet and bring it to class tomorrow.